In this video, I will tell you all you need to know about rules of exponents and the rules of roots. I will tell you how the rules are working and why they actually work. In the beginning, it's quite simple, and at the end, maybe a little harder. In part 2, I will go through a lot of example questions, so please look at this part 2. And here are the rules I cover in this video. The first 8 of them are from the Swedish formula sheet, and the 3 below is kind of bonus rules for roots and this sort of stuff. So, rule number 1. The rule are when we multiply 2 powers with each other and when we have the same base on each power. The same letter A are used here, and that tells me that we need to have the same number in the bottom. And then it tells me that we can add the exponents and write it like this. A quick example for how it works. If you have this multiplication, then you can write it like this. You add 3 and the 4 in the exponents, and it equals 2 raised by 7. But why does this work? Okay, I write it in colors like this. And the first 3 2's can be written like 2 times 2 times 2. Last 4 2's, the blue ones, can be written like this. And then we have 7 factors. And now you can write it like 2 raised by the sum 3 plus 4, and then it equals 2 raised by 7. Next rule is rule number 2, I think. It tells us that if we have a division of 2 powers with the same base, you can subtract the exponents like this. And a quick how it works. If you have an example, 2 raised by 5 divided by 2 raised by 3, it means that you can write it like 2 raised by 5 minus 3. It will become 2 raised by 2. And of course it means that you have 2 2's and multiply them with each other, and then it equals 4. But why is this working? I will write it like this with colors. And in the numerator we have like this. We have 5 of the 2's multiplied with each other. In the denominator we have 3 2's multiplied with each others. And if I take my pencil and divide up and down with 2, and then again with 2 up and down, and again with 2 up and down, we get an invisible number 1 at the bottom, but we don't need to write it down. But the result here is that we got 2 2's left. So we can write it like this. The number of 2's we got left, we get it from the numbers we had at the numerator at the beginning, minus the numbers of 2 in the denominator. So 5 minus 3 as the exponent, and then it equals 2 raised by 2, of course. Okay, rule number 3. A raised by x raised by y equals a raised by x times y. And a quick example first. How? If you have like this, 7 raised by 2 raised by 3, you can write it like a product in the exponent, 2 times 3. And then it equals 7 raised by 6. But why is it working? I will color it like this. And the number 3, the blue one, tells us that it is 3 factors of the power 7 raised by 2. So you can write it like this. 7 raised by 2 and times itself in exactly 3 examples. And each of these powers here is 7 times 7. So you can write it like this too. So 7 times 7, and then 7 times 7, and then 7 times 7. So each power gets a parenthesis. So we have 3 parentheses, and each parenthesis have 2 factors inside it. So these numbers here, the exponents, tells us the 3 is the number of parentheses and the 2 is the number of factors inside the parentheses. And the total factors is the product of these numbers. So we got 6 sevens in total, 2 times 3, and then we can write it 7 raised by 6. Now we're jumping ahead a little bit and we go back to rule number 4 later. We take rule number 5 first. So when you have a multiplication with 2 powers and the exponents are the same, then you can use rule number 5. But you can always use any rules from right to left too, and maybe it is more often that you do this with this rule. But first, we take a quick how it works. If we have like this, we have the same exponent, 6 raised by 3, and then times 2 raised by 3. You can multiply these bases with each other. 6 times 2 equals 12, so we can write it like this, and then like this. So it equals 12 raised by 3. And why is it working? So I write it like this, and the 3 sixes, we can write it like 6 times 6 times 6, and then 3 of the 2's, 2 times 2 times 2, and then we shuffle around them and pair them like this. So 6 times 2, it will be 1 factor, like this, and then 6 times 2, and then 6 times 2. It is the same no matter which order you place the numbers in. The product will be the same. And then we got 3 factors, 3 parentheses, and then we can write it like 1 parenthesis raised by 3. And then we have it. Then it equals 12 raised by 3. And now it's time for rule number 6. It is when we have a division with the same exponents in the powers. And then we can divide the bases first and then raised by the exponent. And it is very common that you do this from right to left also in this rule. Okay, so 10 raised by 3 divided by 5 raised by 3. You can divide 10 and 5 first, and then it gets 2 raised by 3 at the end, and it equals 2 times 2 times 2 equals 8. And why can we do this? We can write it like 10 times 10 times 10, and then divide by 5 times 5 times 5. And then we can write the fractions separately. So 10 fifths times 10 fifths times 10 fifths. And then we got it. 10 fifths raised by 3, because we have 3 factors of 10 fifths. And of course, 10 divided by 5 in the parentheses equals 2. So it becomes 2 raised by 3 equals 8. Now it's time for rule number 8. And we go back to rule number 7 later. Rule number 8. Any number raised by 0 equals 1. But in most of mathematics, we are told that a can't be equal to 0. And it is that 0 raised by 0 is undefined. And why is it like this? Because if you have this rule here, and if you have 0 raised by any number, the exponent will tell us how many factors of 0 it is. But no matter how many factors of 0 we have, we always get the result 0. 0 times 0 equals 0, of course. And it is rather hard to combine this rule with this rule. And yeah, 0 raised by 0, it is hard to convince anyone that it equals 1. So it is undefined in most of the mathematics. But how? Give me an example. Yes, take 3 raised by 0, it equals 1. Another one. 4x minus 3 plus pi equals 0. It equals 1. If the parentheses are not equal to 0, of course. But why is it like this? We start with a funny little thing, this expression here. 5 raised by 2 and then divide by 5 raised by 2. And this expression can be written on 2 different ways. We can use rule number 2, I think, and it tells us that it equals 5 raised by 2 minus 2. And this is equal to 5 raised by 0. But we can also argue that it equals 5 times 5 at the numerator and divide by 5 times 5 in the denominator. And this equals 25 divided by 25. And this equals 1. So the answers here must mean that 5 raised by 0 equals 1. This is the same thing. I write it like this. Because if we have the same thing at the start, we must have the same thing at the beginning, because we have used equal sign all the way, like this and like this. So you can go from here and then to here and then to here, and then 5 raised by 0 equals 1, and then it's 2 for other bases than 5, 2, with the same principle. Next rule is rule number 4, and it is related to rule number 8, the explanation to why it works. So first, how do it work? And if we have an example, 3 raised by minus 2, you can change the sign in the exponent if you take the whole power and put it in the denominator instead. So you can write it like this. You put the whole power here, but you change the sign from minus 2 to 2. And then number 1 will be visible in the numerator. So it equals 1 divided by 3 times 3 equals 1 divided by 9. Another example. We have 2 times x raised by minus 3. Then you can write it like this. The power is only this thing, because the number 2 isn't inside the base. So the exponents only works on the number x here, on this expression. So this power, you can, in the long way, you can do like this. You write the number 2 in front and then 1 divided by x and change the sign to plus, so this. But the number 2, you can move it up in the numerator, so it will be like this, 2 divided by x raised by 3. And then the fast way to do this is only if you have like this at the first, you can put the power right behind it at the very beginning. So you can write like this from the start. Okay, so I am always thinking about this as 2 floors. We have the basement here, and then we have the ground floor or first floor here. And this thing has no basement, so it is only the ground floor. So you can take a power and move it between floors if you change the sign of the exponents. So change floor and change the sign in the exponent. It is a simpler explanation for this rule. So change floor of this thing, put it down here in the basement, and change the sign in the exponent. And you can do it in another way too. You can do it if you have maybe like this. 3 divided by 2 raised by minus 2. It means you can change floor of both the 3 and the 2 and write it like this instead. 2 divided by 3, and then change the sign in the exponent to this one. And then it means, if you use maybe rule number 6, from right to left, it means 2 raised by 2 divided by 3 raised by 3, no, raised by 2, and then it equals 4 divided by 9. Okay, and now the explanation for why it works. And we start with a funny little expression like with rule number 8. So I start with this expression here. 3 raised by 2 divided by 3 raised by 5. And if you do it with rule number 2, then you can take the exponents, minus each other, and get 3 raised by 2 minus 5, and it equals 3 raised by minus 3 in this little example here. And you can also write it like 3 times 3 in the top, and then divide by 3 times 3 times 3 times 3 times 3 in the denominator. And you can do like this. You divide up and down with 3, and then divide again with 3, and one invisible number 1 pops up, and then it equals 1 divided by 3 raised by 3. So if you look at this one and this expression here, it is the same thing, exactly. So the power 3 raised by minus 3 is exactly the same as if we take the power and put it in the denominator instead, but change the exponent here to opposite exponent with a plus sign instead of minus. So it must be the same thing. And now rule number 7. And it tells me how to rewrite powers as roots and roots as powers. So all the roots, you can write it like powers and vice versa. So an example is if you have maybe 9 raised by 1/2, then it means with this formula you can write it like the square root of 9. And if you have the square root, it is an invisible number 2 here, but we don't write it. You can write it if you want to, but it is common not to write this number. So the square root of 9 equals 3, because 3 times 3 equals 9. And when you use this sign and or write it like this, you mean the positive number that times itself equals the number inside the root. So not minus 3, only 3 when you write it like this. Okay, another example. We take maybe 27 raised by 1/3. And it equals the cube root of 27, and it equals 3, because 3 times 3 times 3 equals 27. So there you have it. And why is it like this? If you take this expression here and this expression here and assume that they are the same thing, then we can take both expressions and it still will be the same thing if you raised these expressions with 3, if we assume they are the same at the beginning. But in the first case, here, then we can use rule number 3 and multiply the exponents. And 1/3 multiplied with 3, it equals like 3 over 3, and it equals 1. So this means if we take 27 raised by 1/3 and raise it by 3, it will become 27. Okay. It also means that raised by 1/3 is the opposite operation or inverse operation to raising by 3. So they will cancel each other out. So shoop, shoop, and we will only got 27. But this thing is the definition by the opposite operation for raising something to 3. It is the cube root. So if we have this sort of thing, then we can cancel this thing and this thing out from the start, and it will become 27. You can write it like third root of 27 times third root or cube root of 27 and cube root of 27. But if you have 3 factors of the cube root, then it equals the thing inside it. It equals 27. So by definition here, they cancel each other out, but they do it in this case too. So this means that this thing inside the parentheses here must be the same as this thing inside the parentheses here. It can't be on any other way. And now it's time for the bonus rules, these 3 rules. And in the formula sheet in Sweden, we don't have these rules, but you can combine the rules above to get these rules. And we start with rule number 9. Okay? And it tells us how to do if we have a power with a fraction as an exponent, and how to calculate these things. And quick example, if we have like this, 8 raised by 2/3, then you can write it like this. So it means you can take the number in the denominator, 3, then it means the cube root here. So the cube root of 8, and then raised by 2. And the cube root of 8 equals 2, because 2 times 2 times 2 equals 8. So it means 2 raised by 2, and it means 4. So, quick rule. This stands for the cube root. So, and this is the exponent when you raised the cube root with something. But you can also write it like this if you take it the other way around. So you can write first 8 raised by 2. So 8 raised by 2, and then take the cube root of this thing here. And 8 raised by 2 equals 64. So the cube root of 64, and then you get, 4. 4 times 4 times 4 equals 64. So 4 again. Okay, did you get it? If we have a thing like this, then the thing in the denominator, it stands for which root it is. So in our case, the cube root. And the thing in the numerator is the exponent. And it is your choice if you take the root first or if you raised it first. You can do it either way, but it is most often smart that take the root first, I think. You get smaller numbers to work with. And why is it like this? So if you take this example, 8 raised by 2/3, it equals 8 raised by 1/3 times 2. Okay, this equals 2/3. And then you can use rule number 3, and it equals 8 raised by 1/3, and then raised by 2. And with rule number 7, 8 raised by 1/3 equals the cube root of 8, and then you have it. The cube root of 8 and then raised by 2. But if you, from here, write it like this, 2 times 1/3 in the exponent, then it will be 8 raised by 2 and then raised by 1/3. And then you can take rule number 7 and write it like the cube root of 8 times raised by 2 equals the cube root of 64. So you can write it like this thing here or this thing here. It is the same thing, no matter the order of the operations. And now it's time for the 2 last rules I have. The rule number 10 and rule number 11. And it is kind of the same thing as rule number 5 and rule number 6. If we write all the roots as powers, and we can do it with rule number 7. So if we take rule number 7, this thing, then we can write this thing with rule number 7, and then it equals rule number 5 and rule number 6. Because a multiplication of two roots is the same thing as a multiplication of two powers if the power here tells us which root it is. So if the powers here are 1/3, then it means it's the cube root. So these rules here, it stands for not just the square root, it's for any root. So like this, and like this, and also here. So for all types of root. So these are working because these are working too. So a quick example, if you have like this, it means it's kind of hard to calculate the square root of 5 in your head, and the same for square root of 20, but it equals the square root of 5 times 20, and it means the square root of 100, and then it means 10. 10 times 10 equals 100. And of course, if we have like this, then we can write it like a big square root of 200 divided by 2, and then it means the square root of 100 in this example 2, and it equals 10. But these formulas are not just true for square roots, it's true for all types of roots, because of the connection here between roots and powers. So if these are true, then these must be true too. Okay, then we have got through all these rules. I hope that you have enjoyed this video, and look out for part 2 with a lot of example questions. Bye bye, I am Jonas, a Swedish math teacher.